Hello and welcome to a new video on Tutorialspedia YouTube channel. In this video, I'll be covering RabbitMQ, which is a well-known message broker, and we will be having a high-level overview of RabbitMQ as a message broker, primarily targeting beginners. Let's look into the details of the topics that we are going to cover in this video tutorial. First of all, we will have a high-level overview of RabbitMQ as a message broker. I will explain the basic concepts that are associated with message brokers in general and what type of problems these message brokers solve. And then we will see that what are the main features of RabbitMQ as a message broker. And then we will look into the core concepts which are associated with RabbitMQ as a message broker. And we will look into the details that different features and different concepts that are available in RabbitMQ, how they relate to each other. And last but not least, we will be looking into the technicalities that how RabbitMQ works and how different components work together to achieve the desired goal of having a good performance in any message broker. I have already created another video on this channel where I covered ActiveMQ as a message broker. And if you are interested, you can watch that video as well. And I also created another video about Apache Kafka as an event streaming platform. You can look into that as well. So now if we look into the overview of RabbitMQ, before that we need to understand that why we need message brokers and what kind of problems these message brokers solve. Basically, when we have multiple heterogeneous systems and applications which need to integrate and which need to communicate with each other in the form of messages, then it's very important that the way these systems and applications are integrated should be in a fault tolerant mode, in a scalable mode, and they should be in a position to perform in a way that they don't become a bottleneck in overall business ecosystem. So the traditional or legacy approach that was followed was point-to-point communication, where we have a source and we have a destination, and both of them are directly communicating with each other. But with this traditional point-to-point approach, the problem is that if we don't have any mediator or any broker in between, then there is a higher chance of any message failures or message retransmissions, as well as lags and delays because the producer and consumer might not be available at the same time. And secondly, the speed or the throughput that is on the producer side, and the number of messages and the type of messages that producer is producing might not on the consumer side, it might not be possible for consumer to handle all those messages concurrently and at the same time. So this leads to a problem where some of the messages might get dropped, some of the messages might get delayed, and also it becomes an additional overhead on the consumer sides, that every consumer has to have the logic of retrieving the messages directly from the producer, and the protocol support, versioning support, data format supports. All these things might be an added overhead on different type of consumers, because not all the consumers might be having the similar features. Some of the consumers might be supporting data in a different format. Some of them might be supporting different type of protocols. That might be need of a protocol conversion on the client side itself, or maybe on the producer side, to make sure that it is producing the message as desired by different consumers. But when we see this situation, then there is a solution to this type of problem, which is to have a message broker in between. So what happens is that if we have a message broker in between, then many of these responsibilities of handling the data formats, data versions, protocol versions, and message queuing, message transmission, ensuring the messages are persisted in case of any failures, and making sure that messages ordering is the way message needs to be consumed or provided to the consumer is in the correct order. So these type of features are all in a message broker, which sits in between the producer and the consumer. So what happens is that now with the approach of having a message broker, a producer is not going to directly send a message to the consumer. Rather, it's going to have intermediate option, or a broker, which is the message broker, which is going to deal with the consumers on behalf of the producer. So a producer is going to simply produce the message and push it to the message broker. Now, which consumers are going to receive those messages, which consumers are interested in what type of messages, and all these features and all these things, and how the messages are going to be persisted, how the message redelivery is going to be entertained, how the message time to live and message expiries are going to be handled. This is going to be entertained, and this is going to be dealt by the message broker. So if we talk about message brokers, there are different type of message brokers in the market with different protocol support and different technologies internally. And there are some open source, as well as there are some proprietary message brokers available. And in this video tutorial, we are going to look into RabbitMQ. So RabbitMQ is a well-known open source and a popular message broker, which is in the market for quite long. And it is being used by various organizations to achieve the desired messaging goals in their businesses. And it is, if we talk about the technicalities of this RabbitMQ message broker, this is based on Advanced Message Queuing Protocol, AMQP. But the good feature and the good thing about this RabbitMQ message broker is that it has support for multiple protocols, which makes it more convenient for different type of applications, be it legacy applications, be it some open source applications, or even proprietary applications, to be able to to be able to integrate with other applications using this RabbitMQ as a message broker. Some of the examples of the protocols are HTTP, MQTT, and STMP. So with the support of multiple protocols, it becomes quite a flexible option for any organization to opt for RabbitMQ as a message broker. And as I explained that when we have a message broker in between, so it enables a loose coupling of our messaging based integrations, because now the producer and the consumer are not tightly coupled with each other. Rather, the coupling has been loosened, or rather, it's a complete. You can say it's a decoupled messaging environment now, because producer doesn't care if the consumer is available at the same time, and if the consumer is able to consume the messages at the same rate as the producer, because these things are now being handled by the message broker. And when we talk about the performance and the features of RabbitMQ, it's equipped with fault tolerance, high availability, and scalability features. So even if your organization requires this messaging platform or message broker to be in a high available mode or in a FT mode, and if you want to achieve a certain level of scalability, you want to scale it up or scale it down, you can do that as well. I'm not going into the technical nitty-gritties of RabbitMQ in this tutorial, as the purpose and the scope of this tutorial is to explain RabbitMQ at a high level, primarily targeting the beginners. So now let's look into some of the core concepts which are associated with RabbitMQ. And most of these concepts are not specific to RabbitMQ, rather for any message queuing or message queuing platform or a message broker. Most of the concepts can be related. So the basic concept that when we talk about message brokers, or when we talk about RabbitMQ in specific, is the messages. So messages are the basic ingredient of these type of platforms, where a producer produces a message, and all the communication that happens from the producer to the broker and from between the broker and the consumer is in the form of messages. So when we talk about messages, messages contain the useful information that the producer wants to share or communicate with the consumers. And messages construct is in a way that it contains header, which contains the required metadata about the message. Then it has the body, where the actual content of the message is written, and then it has the properties. So there can be additional properties which are associated with any message. And then we have message producers. A message has to be produced by a producer. So what happens is that we have we can have multiple applications or systems which act as the producers for the messages, and these producers are going to produce the message. And once they produce the message has to be sent to the required destinations at the broker level. The destination, when we say destinations, we mean queues. But it is in case of RabbitMQ, any producer that produces a message is not sending the messages directly to the queues. Rather, we have exchanges in between. So exchange, in terms of its technical explanation, you can consider it as a routing manager, which is responsible for managing all the routing of the messages to the desired queues. So what happens is that once we have a producer which produces a message, it doesn't send directly to the queue. Rather, it sends the message to the exchange, and then there is some association between the exchange and the queue in the form of a binding. So based on that binding, these messages are sent from the exchange to the desired queues. And then we have the concept of consumers. Consumers, in case of a messaging platform, are those applications or systems which are interested into the messages which have been produced by the producers and sent to the queues. So these consumers are associated with these queues on the message broker, and then they get the messages from the queues, and then they consume the data and achieve the desired goals, whatever business goal is associated with those type of messages. And as I mentioned that there is a relationship or there is a correlation between exchange and queues in message broker, and that is through binding and routing keys. Whenever a message is produced by the producer, message is sent using a routing key. So this routing key, and then there is a binding between the queues and exchange. So this routing key is used to decide the binding. We have different type of exchanges which we will cover in subsequent slides of this video tutorial, where we will explain that in which type of exchange what role a particular routing key plays and how we have a binding between queues and exchanges. All right. So now let's look into the exchange types. This topic about the different exchange types that are available in RabbitMQ is a vast topic, and I will try to make another video where I will explain it in much detail with the example. But here we will be covering it at a high level, primarily the core concepts. So if we talk about the type of exchanges, there are majorly four type of exchanges: direct exchange, fan out exchange, topic exchange, and header exchange. And then we will also see that how we have default exchange and dead letter exchanges as well, which fall under the subcategories. So if we talk about a direct exchange, in case of a direct exchange, there is a binding between the binding between the routing key and the binding key between the exchange and the queue. So what happens is that whenever you send a message to a direct exchange, and a producer sends a message by specifying a routing key. For example, if a message has been produced by a producer and the routing key of the message is tutorialspedia, then this message, when it reaches to the exchange, which is acting as a routing manager, it will see if there is any queue with the binding key exactly same as the tutorialspedia. So if the binding key of a queue matches to the routing key of the message, in that case that message will be delivered to that particular queue. Okay, so in this case, there can be a possibility that we have multiple queues with a binding key exactly matching. So in that case, this message will be delivered to all those queues which have binding key equal to the routing key of the message. Okay, so the second type of exchange is fan out exchange. So fan out exchange is kind of you can consider it like a broadcasting exchange. So what happens is that when we use fan out exchange, then it sends any message that is sent to a fan out exchange is broadcasted to all of the queues irrespective of the routing key. So in this case, even if you specify a routing key with the if even if producer specifies a routing key, it's ignored. So once a message comes to a fan out exchange, it is communicated, or it is made available to all of the queues which are part of that message broker, and which have a binding with that exchange. And then we have a topic exchange. This is the type of exchange which is used for the wildcard associations between the exchange in the queue. So what happens is that whenever a producer sends a message to a topic exchange with a routing key, and then all of those queues which are bound to that topic with a wildcard, with the wildcard association, will be receiving the message. As an example, let's suppose that we have a producer which produces a message with the routing key tutorialspedia.info.message, and it produces another message with the routing key tutorialspedia.alert.message. And then we have some queues which have the binding with the with this topic exchange as tutorialspedia.static.message, as an example. So in this case, anything in this wildcard, no matter it's tutorialspedia.info.message or it's tutorialspedia.log.message, .alert.message, so all these messages once reach to the topic exchange will be provided or will be made available to all of these queues. So in this way, we can have a wildcard based association between the topic exchange and the queues. And last, we have header exchange. In case of header exchange, what happens is that we have two options. Whenever a message comes to the header exchange, if we have specified that it has to check for to match all of the header properties, or maybe even one of the header properties. So we have option X match any, or we have option X match all. So based on this, it decides which particular queue this message should be sent from the exchange. If it's X match any, then even if one of the header property is matched between the message header and the routing and the binding, then it will be sending the message to that queue. And if it's X match all, then it will be checking for all of the headers. So if all of the headers match, only then this message is going to be sent to those queues. And if we talk about some of the additional concepts related to the exchange types, we have default exchange and dead letter exchange as well. These are not falling under the main categories, but I am covering these as well at a high level. So the default exchange, basically what happens is that it associates routing key with the queue name. So this default exchange is an exchange without any name, and it's by default available. So what happens is that whenever you send a message to the default exchange, I mean with the exchange having no name, and then this direct exchange, this type of direct exchange, which is default exchange, it will see that it will use the name of the queues as the binding. So based on the name of the queue, it will be sending the messages to all the queues which have the same name as the routing key. Of course, there will be one queue in this case with the name same as the routing key. So in this case, the binding is not based on a separate binding key, rather it's just based on the name of the queue. And then we have another concept which is dead letter exchange. So what happens is that whenever messages are sent, so any messages which are negatively acknowledged, or any message which reached to the TTL, time to live and expired, and this type of messages which are not handled by the queues are not being lost. So if you have a dead letter exchange available and it has an associated dead letter queue as well, so what happens is that all those messages which are negatively acknowledged or which have reached to the expiration, instead of getting them lost at all, they are being sent to this dead letter exchange and then stored into the dead letter queue. So in this way, you can keep track of all those messages which have been sent to the message broker but haven't been consumed correctly, or haven't been entertained and acknowledged by the queues or the consumers from the queues, and these messages are still available for your information in the dead letter exchange. So as I explained that I'm not going into the nitty-gritties and much of the granular details of these exchange types. I will try to make another video in future with the examples for all of these exchange types and how they work. Now at a high level, let's look at that how RabbitMQ as a message broker works. So in this picture, you can see we have producers. We have two producers. We have P P1, P2. You consider them as P1, P2. I mentioned both of them as P. So we have two producers on the producing side, which are producing the message. And we can see that at a message broker level, we have X1 and X2, which are the two exchanges. So what happens is that a producer can send a message to either one exchange, or even it can send a message to multiple exchanges. You can see first P, which is the first producer, is sending the message only to X1 exchange, but the second producer is sending the message to two exchanges, X1 and X2. And once it reaches to the exchange, as I explained earlier, that we have different types of exchanges available. So based on the type of exchange and based on the association or based on the binding between the routing key and the binding key of the queues, it decides that this message needs to be sent to which queues. So it's possible that this message might be sent to only one queue. It's also possible it is sent to multiple queues, and it's also possible that it is sent to all queues. So depending on the type of associations and depending on the type of exchange. So once these messages have been sent to the queues, then we have the on the consumer side, you can see that we have multiple consumers, and these consumers are consuming the messages from those queues. So these consumers receive the message and acknowledge those messages, and then this complete cycle of the way messages are produced from the producing side, they are sent to the exchange, they are stored into the queues, and then they are consumed from the queues completes. So this is at a high level how RabbitMQ works as a message broker. So that's it from this video with just a high level basic concepts explanation of RabbitMQ. Of course, there is a lot more yet to be covered and need to be dig further. If you want to learn more, you can go to my website tutorialspedia.com, and also you can read official documentation and details about RabbitMQ on the RabbitMQ's official site. And this uh, type of platforms have a lot of details and a lot of information that needs to be grasped, and one video alone will not help you to understand everything that is associated with these type of platforms. But this is just a beginning, and more is yet to come. And again, don't forget to subscribe to the channel, tutorialspedia.com YouTube channel, if you haven't subscribed before, because we will be having more videos related to message brokers as well as other integration technologies in future. Thank you very much.